I'm Mason Veruso.
And I'm Dominique Galvez.
This is OPTI 388 under Raphael.
Lab 7, Michelson Interferometers.
The purpose of this experiment is to calibrate our Michelson interferometer. We do this by recording 100 fringe movements on this slide right here, and then from there, we look at the difference in micrometer movement. That'll give us the calibration factor.
And now that we have the calibration factor of this interferometer, we can use it to find the wavelength of an unknown source. To do this, we use this equation, and we will find the distance moved by this micrometer over a certain number of fringes.
For our results, we found the wavelength to be 486.7 nanometers. If we had counted off by one fringe, our error would have been 1.01%. In order to find the wavelength within 0.1 nanometer accuracy, we would have counted 485,700 fringes.
The same as the last experiment, we will use the calibration factor and the interferometer to find the wavelength of this sodium source.
When adjusting for the darkest fringes, we get the highest fringe quality when the two wavelengths making up the source constructively interfere the most. When we move the micrometer through a large range, we notice that the fringes will fade out, come back as really bright and dark, and fade out again repeatedly.
The purpose of this experiment is to find the wavelength separation of this sodium source with the interferometer. So to do this, you find the null by looking through the porthole there, and then you go through the micrometer until you find the next null, and that is the change in distance. So then you can use this equation with the lambda you found in the last experiment to find your delta lambda, which is your wavelength separation. For our results, we discovered that the wavelength separation was 0.45 nanometers, and this yielded a percent error of 24.9%.
The purpose of this experiment is to use a Michelson interferometer to measure the refractive index of air. To do this, we vacate pressure from this chamber until it's at a vacuum. Doing that, we count a difference in 20 fringes. That will be able to be graphed and then will give us the refractive index of air. The results of this experiment are shown in this graph. This graph shows the change in refractive index with regards to change in pressure. We found the refractive index at room pressure to be 1.00024.